Okay, so as I mentioned, today is September 1st. Oh, do you guys hear an echo?
Yes, miss.
1 second, let me get rid of that echo. Okay, echo should be gone now. So, as I mentioned, today is September 1st. Our weekly objectives, we are continuing with classifying numbers, distinguishing numbers, and then we want to describe number patterns today as well. So today's lesson is still about classifying numbers. You want to finalize all the number theory. So natural, whole, integers, rational, irrational. You want to finalize that so that you guys have a solid idea of what it is that we're talking about. So now natural numbers. And I went ahead and I made a slide for each one so that you guys could have examples and you know what I'm talking about. So the first one is, what are natural numbers? So how do natural numbers look like? And natural numbers are basically your counting numbers, and these ones should be the easiest ones for you to be able to identify. So 1, 2, 3, 4, 5, 6, all the way, and I could include 100, 145, 260, 897. All of those are counting numbers. Those are the regular numbers that we use. So if you see and I give you a number that is 875 and I tell you what kind of number is that, then the first thing that you're supposed to tell me, okay, that's a natural number. That's a counting number. All right, it's a regular number that I'm using. Moving on. A whole number now. Whole numbers are all the natural numbers and the number 0. So whenever I give you the number 874 and you tell me, okay, that is a counting number, it is also going to be a whole number. So every time that you put that a number is a natural number, it is also going to be a whole number. So every time that in your table, if I'm going to check that number 2 is a natural number, yes, a natural number, then I also have to put a check mark on whole number so that you know, because all of the natural numbers are under the whole number. Now, in addition to all the natural numbers, the whole numbers have one more number added to it. What is that number? Anybody? The set of whole numbers has all the natural numbers. So what I'm saying is that if you see the whole numbers that I have right here, all of the natural numbers are there. But there is one more number that is added to this set. What is that number?
Zero.
0. Very good. And I saw it in the chat as well. 0. So 0 is the only number that is not going to be a natural number. It is not going to be one. Okay, sorry about that. So, moving on. What are integers? Now, integers are all the natural numbers, all the whole numbers, and the negative numbers, right? So, these are -4, -3, -2, -1, 0, 1, 2, 3, 4. There are no decimals and there are no fractions, right? So if we see, for example, -half, Is negative half an integer?
No, miss.
Very good. It is not an integer. Even though it is negative, it is not an integer because integers only talk about numbers, entire numbers. So you can have negative 20, that is an integer, but I cannot have negative 3/4 because that is not a whole number. All right? And what about if I have negative 2.5? Is that an integer?
No, miss.
No,
No,
it is
miss.
not. Very good. It's not an integer. What are rational numbers now? All of the natural numbers, all of the whole numbers, and all of the integers are rational numbers. Plus, we have square roots, we have fractions, and we have decimals. All of these things are rational numbers. Now, why is square root of 4 a rational number? Because it is a perfect square. Why is negative root 9 a rational number? Because it is a negative perfect square. And when I mean perfect square, it is because 2 times 2 gives me 4. 3 times 3 gives me 9. 4 times 4 gives me 16. 5 times 5 gives me 25. 11 times 11 gives me 121. So when we're talking about if I can write a number as a fraction or not, then you have to know your times table very, very carefully, right? So that you guys could see, okay, the root of 4, that is 2 because I know that 2 times 2 is 4. Fractions. All the fractions are rational. It does not matter if they are negative or positive, but all of them are rational numbers. And decimals, only some decimals are rational. So we have to be careful here. Only some of them. Now, which ones are rational? Only the decimals that I can write as a fraction. So if you don't know which decimals those are, you could easily go to your calculator and you could do that. You change it to a fraction. For example, 2.5. Who can tell me what is 2.5 as a fraction?
Two and a half.
Very good, Ernest. 2.5. What about 3.75?
Three and three quarters.
Very good, 3 3/4. And then how about 5.1?
1/5.
No, it's not 1/5. 5.1 is 5 and 1/10. Alright? So all of those are fractions that I can write as a decimal. I mean, all of those are decimals that I can write as a fraction, right? So with rational numbers, we have to be careful that we don't confuse them with irrational numbers. So rational numbers, some square roots are rational, all the fractions are rational, and some decimals are rational. And we have all the integers, all the natural numbers, and all the whole numbers. Now, irrational numbers, and we leave irrational numbers last because those are the ones that are all by itself. So everything that is not irrational, that is not whole, that is not natural, that is not an integer, falls under this set of irrational numbers. So we have some square roots, and we look at these square roots. We have the square root of 2. Can somebody tell me what number times itself gives me 2?
4. No one, miss.
No. 4 times 4 gives me 16, and 1 times 1 gives me 1.
Oh. What was the question, miss?
What number times itself gives me 2?
No number, miss.
There is no exact number.
Don't.
There is an answer, and you do have a calculator. You go on Google and you put square root of 2. It's gonna give you an answer, and it's gonna give you a big decimal. All right. So it is an irrational number because the answer that I get is a decimal that I cannot write as a fraction. And the same thing with 5. What number times itself gives me 5?
No number.
It's not an exact number, right? I can find the answer for that, and you can find the answer for that, but it's not gonna be a number that I can write as a fraction or an exact number. And the same thing with 67. What number times itself gives me 67? It's not an exact number. There is not an exact value that gives me 67. Going to the second row now. Repeating decimals. All the repeating decimals are irrational. What does that mean? It means that there are certain decimals that have the same numbers over and over and over and over and over. For example, 0.67676767 going on forever, never ending 67. And you have the number 4.3333333333, never ending tree. And there are two ways how this can be represented. It could have the decimals at the end, not the decimal, sorry, the ellipsis at the end. So I could have these three little dots here. So 67, 67, 67, and then the three little dots. Or I could have 4.33 and then the little bar at the top. And the little bar means the same thing. It means that those numbers are repeated and repeated and repeated. All right? And then now we go to our last set. We have numbers that are never ending. And when I mean never ending, it means that all of them are different numbers and you have different numbers happening there. So the difference is that in the middle set, we have repeating decimals, meaning that you repeat the numbers over and over and over. And in the one at the bottom, you have non-terminating decimals, means that it goes on forever and ever and ever, but each time it is different numbers that are used in the decimal. Right? So is this clear to everybody?
Yes, miss.
Good. So now
Yes, miss.
yesterday, this is what we were working with. We had reached to the point where we had color-coded some of these. We put green as being a whole number, rational and integer. So that is what we had put there. 0. Negative 3/4, we had colored it orange because it is only a rational. Negative 60, we had colored it red because it was irrational. Pi, we had colored it red because it is irrational. 9.564, never ending, non-terminating, we had colored it red because it was irrational. And the negative 47, we had colored it yellow because it was an integer and a rational. Do we want to change anything from here? Or are you guys okay with those answers that we have?
It's good, miss.
It looks good? Very good, because all of them are correct. So, let's look at 4.32 with the little bar at the top. What kind of number is that?
Irrational.
Very good. It's an irrational number. So I'm gonna color this red because it's irrational. Very good. It's irrational because the little line at the top means that it continues and repeats the same numbers, right? 3.5. What kind of number is 3.5?
Rational.
Okay, is it rational only or is it a rational and something else?
Rational numbers and integer.
Are we sure? See, integers are only these ones. Only a whole number, right? Rational numbers are these ones. So if we come here, what is 3.5? Is it a rational only or is it a rational and something else?
It's a whole number.
But it's 3.5. Is 3.5 a whole number?
Miss, it's a rational integer and whole number.
Okay, let's look at this one. A whole number. What are whole numbers? The whole numbers are 0, 1, 2, 3, 4, 5. Do we have 3.5 there? Yes or no?
No, miss.
No. Integers. Integers are -4, -3, -2, -1, 0, 1, 2, 3, 4. Do we have 3.5 in integers? Yes or no?
No.
No, we don't.
No.
So where do the fractions go? Where did I say that the fractions go?
Rational only.
Rational only. Very good. Rational only. So we're going to color this one orange. So whenever you see a fraction, all the fractions go in rational. Automatically, you should know that. When I see a fraction, okay, a fraction is a rational and it's only going to be a rational. It's not going to be anything else. I have this number. Where does this number belong to, or what kind of number is this?
Irrational number.
It's not an irrational. Who can read that number for me?
Nine million 342,029.
Very good. It's 9,342,029. What kind of number is that now? Is that a normal number? Where does this number belong to? Anybody?
To whole number.
To whole numbers. Very good, Edwin. Whole numbers. Now, what did we say at the beginning? That whole numbers are also what kind of number?
Rational.
Rational number. What else?
Natural number,
Natural.
Natural number. What else?
Integer.
Integer. So it's four kinds of numbers. So what color do I have to color this one?
blue mist,
Blue. Very
Blue.
good. Blue. Okay. What about 1,000? What kind of number is 1,000?
Whole number, miss?
It's a
Whole
whole
number.
number. What else?
Rational and
Miss,
integer?
rational
Rational,
integer or
integer,
natural.
and natural.
Because it's a
Very
full.
good. So what color?
Blue.
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 Very good. Okay. Negative 5.45. Where would that go?
Irrational number.
No, it's not an irrational number. Remember that
Integer, miss?
remember that for it to be an irrational, it has to be never ending, right? On the other hand,
It's a rational number, miss?
it's a rational number. Very good, a rational. So what color I'm gonna color this one?
Orange.
Orange. Excellent. Orange. Okay. What about square root of 127?
Miss, that's 127 or 121?
Sorry, 121.
Okay.
Is there a number when I times it by itself that gives me 121?
Yes, miss.
Yes, miss.
By 11.
Okay, very good. So now what kind of number is that? Is it a rational or is it irrational?
Rational.
A rational.
Very good. It's a rational
A
number.
rational.
8 over 3. Where do the fractions go?
Irrational number.
A rational. Very good. What about negative 4?
It's an integer.
Integer.
It's an integer and what else?
Irrational number.
Rational.
It's a
Whole number.
integer and a rational. 8 over 4. Where does 8 over 4 go?
A rational.
Very
Rational.
good,
No.
rational. And then 0.98. Where does 0.98 go?
Irrational.
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 No.
Does this decimal never end or does it end?
It ends.
Never
It
end.
ends.
It ends. It ends at 8. It's only 0.98. And because it ends, where does this go?
Rational number, miss. Rational.
Rational number.
Rational.
Very good. Rational. The difference is, and pay attention, when you have a decimal that ends, so 0.98 or negative 45, it ends somewhere, it's a rational. If it does not end, like this one, then it is irrational, right? Okay, any questions?
No, miss.
Very good.
No, miss.
Now, looking at the time, I'm not sure if we won't be able to do this. Okay, this is what I have in Google Classroom, right? We are not going to be talking about what I have in yellow. We're going to do this tomorrow. So we're only going to be doing half of the table today. All right? Now, you guys, I think that you should already have the table drawn in your notebooks. If you don't have it, then you can just write -2 and then you write which ones I'm going to put a check mark on. And we're going to do this together. I already started the first one. If you have the table already drawn, go to your notebook or go to the page where you have it and then you just have to fill it out. All right? So We're only doing half of this table today. The part that is in yellow, that is what we are doing tomorrow, right? So we're doing half of the homework today. Is that clear to everybody?
Yes, Miss.
Yes, Miss.
Very good.
Yes,
Now,
miss.
if you have already sent the homework, no problem. You can unsend it and you can do it again if you have anything wrong. Is that clear?
Yes, Miss.
Yes.
Very
Yes.
good. Okay, so
Yes,
we are
miss.
going to begin. Let me see if I can zoom this a little bit more. Okay, there you go. Number, my first number is -2. So, before you go and do anything, this is what I suggest to you. All of these numbers are what kind of number?
Real number.
Real number. Very good. So under all of these, you should have, all of them should have a check mark for real. All of them. You're not going to skip anyone because all of them are real numbers. So all of them should have a check mark for that. All right? Now, irrational number. Let's look at number 2. What kind of number is number 2?
Rational.
It's a rational. Very good. I'm going to put a check mark there. What else?
It's
Integer.
an integer.
An integer. Very good. Anything else?
A whole.
Is it a whole number?
No.
No, it's not a whole number. So I'm going to put an X. How about a natural? Do we count with -2? Is it a natural number?
Mm,
No, Miss.
No, it's not. Very good. And we have finished the first one. Easy, right? Very, very easy. Let's do the other one. Half. Is half irrational?
no.
No, it's not.
No,
Very
miss.
good. Is half rational?
Yes.
Yes,
Yes.
Miss.
Very good. It's rational. Is half an integer?
No, miss.
No, it's not. Is it a whole number?
No.
Yes.
No, it's not. Is it
No.
a natural number?
No.
No.
No, it's not. Okay, very good.
Vamos. Vamos.
Guys, make sure that you are mute. Okay, let's continue. 100. Is 100 irrational?
No, miss.
No, Miss.
No, it's not. Is it irrational?
Yes, miss.
Yes, it is. Is it
Yes,
an
miss.
integer?
Yes, miss.
Yes, it is. Is it a whole number?
Yes, miss.
Yes.
Yes, miss.
Is it a natural number?
Yes,
Yes,
miss.
miss.
Yes, very good. 53. Is 53 irrational?
No, miss.
No, it's
No,
not.
miss.
No, no.
Is it irrational?
Yes, miss.
Yes, it is. Is it an integer?
Yes, miss.
Yes, yes.
Is it a whole number?
Yes, miss.
Is it natural?
Yes, miss.
Yes, miss.
Okay, good. 5.12. Is it irrational?
No, miss.
No, it's not.
No, miss.
Very good, very good. You guys are understanding. Is it a rational?
No. Yes,
No,
miss.
miss. No.
Yes.
Yes or no?
No,
Yes.
miss.
Yes,
Yes.
it is. Yes, it is a rational. Is it an integer?
Yeah.
No.
No.
No, it's
No.
No,
not.
miss. No.
Is it a whole number?
No.
No, it's
No.
No.
not. Is it a counting number?
No, miss.
No, miss.
No.
No, it's not. Very good, very good. Um, Square root of 20. Is the square root of 20 irrational?
No,
No.
miss.
No, miss.
Is there a number that when I times it by itself, it gives me 20?
Yes, miss.
Which
Yes,
number?
miss.
No, miss.
10. Oh, wait.
5, miss.
5 times 5 gives me
No.
25.
No.
No.
10.
10 times 10 gives me
5 times 4.
100.
No,
Yes,
and
miss.
miss.
There is no number that when I times it by itself, it gives me
No.
Yes, miss. 5 times 4.
But that's not the same number.
Hmm.
Those are two different numbers. So, the square root of 20 is an irrational number. Is the square root of 20 rational?
Yes, miss.
No, miss.
No, it's
No,
not.
miss.
Is it an integer?
No, miss.
No. Is it a whole number?
No, miss.
No, it's not. Is it a natural
Yes.
number?
No, miss.
Yes.
No,
No,
it's not.
miss.
Now, I want you guys to pay attention to this one very carefully. The square root of 20 is irrational. And because it is irrational, that means that everything else it cannot be the other numbers. Remember that in our drawing, an irrational number was all by itself on the side? So whenever you get an irrational number, it cannot be the other numbers because it's all by itself. Right? So every time that you get an irrational number, a yes for an irrational number, it means that everything else has to be an x because it cannot be anything else. Yes? Okay.
Yes, miss.
212. Is 212 irrational? Yes or no?
No, miss.
No.
No, miss.
No,
No,
it is
miss.
not. Very good. Is it rational?
Yes, miss. Yes.
Yes,
Yes,
miss.
it is. Very good.
Yes, miss.
Is it an integer?
Yes, miss.
Yes, miss.
Is it a whole number?
Yes,
Yes,
miss. Yes,
miss.
miss. Yes,
Is it
miss.
a counting number?
Yes, miss.
Yes,
Yes, miss.
miss.
Yes, miss.
Yes, it is. Very good. 5 over 12. Is 5 over 12 irrational?
No, miss.
No, miss.
No, it is not. Very good. Is it rational?
Yes,
Yes,
miss.
miss. Yes, miss.
Is it
Yes,
an
miss.
integer?
No,
No,
miss.
miss.
No,
No,
miss.
miss.
Is it a whole number?
No, miss.
No,
No,
miss.
miss.
Is it a counting number?
No,
No,
miss.
miss.
No, miss.
No, miss.
No, very good. Now, 0.33333, never
It's
ending
an
3.
irrational, miss. It's an irrational.
It's an irrational. Very good. So now, because it is an irrational, what does it mean for the other ones?
X.
There.
They are not.
So for all of these, we're going to have an X because it cannot be any of them. Alright? The last one now. 64. Is 64 irrational?
No,
No,
miss.
miss.
No.
miss.
No, miss.
Is it rational?
Yes, miss.
Yes, it is.
Yes.
Is it a integer?
Yes, miss.
No, miss.
Yes.
Yes,
Yes,
miss.
miss.
Yes, it is. Is it a whole number?
Yes.
Yes,
Yes,
miss.
miss.
Yes, miss.
Is it a counting number?
No, miss.
Yes,
Yes,
miss.
miss.
Yes.
Yes, miss.
May 100 at this day. Oh, may 100 na agad.
Okay, so there you have half of the homework, right? Tomorrow we're gonna do the other half. So this PowerPoint is in Google Classroom. If you didn't get to write everything, the PowerPoint will be there. You can open the PowerPoint and go to this slide, and then the video will also be posted for you guys. All right. Now, moving on. If you have checked the other homeworks, then this is the other one that I have posted. And this is the only one that we can do. We can only do half of this homework as well because the other diagrams talk about composite and prime and odd and even, which is what we're doing tomorrow. All right? So now what we're going to be doing here and what you guys have to do is that you have to draw something like this in your notebook and you're going to put in the numbers where they belong. All right? So we have 5 minutes. Do you guys think that we can do this in 5 minutes? Yes?
Yes, miss.
Yes.
Yes, miss.
Okay.
Yes, miss.
Okay. Let's see then. So what I'm going to be doing is that you're going to tell me where it belongs and I'm just going to put it there, right? So let's see square root of 2. Where does square root of 2 belong?
Irrational.
Where?
Irrational.
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 Irrational?
Irrational.
Irrational.
Okay.
Irrational.
Okay, how about
Yes, miss.
negative 5?
Yes, miss. Yes, miss. Integer.
Integer.
Integers, very good. Integers. What about negative 20?
Integer. Integer.
Integer, very good. What about 248?
Whole number.
Whole
Natural.
numbers, very good. Whole numbers.
Yes, go back. Eh,
3 over 4.
Irrational. Rational. Rational.
Rational, very good.
Rational.
What about half?
Rational.
Rational, very good. What
Rational.
about negative 4?
Integer.
Integer.
Integers. What about 0.66 never ending?
Irrational.
Irrational.
Irrational, very good. What about 50?
Whole number.
Whole. What about 126?
Whole number.
Okay. And there you go. So, this like I said is half of the assignment. Tomorrow we're going to be doing the other half together, all right? So now you guys can start writing these halves and have them neat, and then tomorrow we only do the other half because these homeworks are due when? When are these homeworks due?
Friday.
Friday, miss.
Friday.
Friday, very good. Friday. Okay, so